In the next 40 minutes or so, we are going to practice a feat that makes HEVC look easy. We're going to take 4 experts in the area of the things about Ultra HD that are more than just the dots, the pixels, how many things are on the screen, and give you an overview and an introduction, by no means any depth. That would be impossible in the time. Be advised that much of what you will see go by in very rapid form here will have expanded versions available on the web along with the recording of these sessions. And with that, I'd like to ask Joe Kane to begin this process by giving the shortest presentation he has ever been known to give.
Target there. My slides will come up in a minute. And this is going to go through rapidly. I think the most important point that I need to make, or I'd like to make, is that there are a large number of people who have HD TV sets at home, and there are far fewer that have ever seen high-definition television. And I see UHD as an opportunity to fix that. So if I'm going through these slides really rapidly because this is there's a lot to be covered here. This is the UHD TV set in my home. So I have it, I have a lot of experience with it, and we have a lot of people coming into my home to actually see UHD TV. I'm hosting a lot of committee meetings on what it should be. We'd like to have UHD be a lot more than it is. And so part of the history of it's UHD, or the 2160p format, or the real 4K format, is about 21 years old. It's been around a long time, and it's now coming to consumers. In other words, we've been producing at a quality level that has never been delivered. So among the things that I have hopes for the UHD format is that it is going to bring an opportunity, or there will be an opportunity to bring to the consumer much more of what we've been producing in the television industry. Now, we've evolved in what we're doing. There's a whole bunch of things that have been proposed for UHD, such as colorimetry. You hopefully all recognize the diagrams. This is surface colors and, of course, the old NTSC specifications. I'm going to go through this really rapidly. This is what we're currently doing today. And, of course, the desire among things in UHD is to bring better color, better bit depth, essentially better pixels. And I'm really having to go through this quickly. But in color, this is basically what sunlight looks like in my backyard. I put an 18% gray card down on the ground and photographed it with a spectroradiometer. This is what a CRT, the color of red, green, and blue, looks like in a CRT. When I brought my projector out on the market, the bandwidth of the colors was quite a bit better than a CRT. Now, proposals are to go to a 20/20 color space. If you look at the diagram, you'll see that the colors of red, green, and blue are right out on the edge of the diagram, which means they're single wavelengths. This is what if we ever get to 20/20 color, this is what it's actually going to look like. And you can see there's little or no bandwidth there in the system. I'm one of the few people that's getting up and saying 20/20 color is not going to work. And there are a whole bunch of reasons that I believe it's not going to work, and I believe that we're eventually going to settle in on something less than the 20/20 space that has been specified in the document. But, and there are lots of options that will give us far better color quality in our sets and yet not go out to 20/20, which I believe is actually going to cause problems. There are papers out there, the Munsell paper in particular, details all of this and why 20/20 color will not work and probably won't work. But the most important thing I think about UHD TV is it's an opportunity to fix some of the reasons that people aren't seeing HD content in their homes now. And I actually want to see UHD include current HD, 1080p and 720p, so that the ultimate ultra high definition system is going to be something that has a benefit to every single consumer, not just consumers who are buying the new TV sets. I'd actually like to have a system that would allow every consumer to take advantage of ultra high definition television. Now, connectivity is a major part of making that happen, because we want to have a higher bit depth, we want to have more frames. There's all sorts of things that we want to have in order to make that system work. Ultimately, incidentally, I want the person who's creating the content to be able to control your TV set and be able to have them set it up so that you get to see the picture that they want you to see. For all of that to happen, the first thing that has to go through is connectivity. The pictures in the background, I'm trying to describe color. If you actually go out and take a look at the flowers in your own garden, you're going to discover the colors in those flowers are greater than anything that our current 709 television system can convey. And so there is value in a larger color space for everybody, that you'll be able to see many more colors. Now, green is another color that doesn't quite come across. Most important point, the 2020 color space can actually cover some of the colors in neon, in this example, colors of light, colors that go out beyond the surface colors. Now, if any of you have been to Las Vegas or just going out in Times Square here in New York, you've seen a lot of neon, and you hopefully recognize that the colors you're seeing up there aren't even close to what the real colors are. So there is an absolute advantage to having a larger color space, and that's going to be part of the system. There's all sorts of other parameters that need to be taken into account. Nobody's talking about grayscale. As an example, if we lower grayscale to D6000, we'll get better color fidelity. And I'm not hearing that in the industry, yet it's something that has to be considered. It's part of the parameters that should be included. High dynamic range, a great deal of the high dynamic range demonstrations have been about specular highlights, so that you can really see on an OLED set, the specular highlights in here would just come out and be just as vivid and bright as they are in real life. The reality of high dynamic range is even more important. This is a picture I shot up in Napa Valley. It happens to be the Sterling winery, but I want to show you the kind of dynamic range that I'm capturing that I cannot show on current displays. So in this particular point, I'm looking at the top of the dynamic range. So we can see there's a wonderful sky and there's lots of detail, but you can see the middle of the picture is sort of missing. So if I bring up the middle of the picture, guess what? I lose the top end of the picture. Can you see how I'm losing the top end of the picture? And of course, if I want to see what's going on in the bottom end of the picture, I'm losing almost everything else that's going on. In a high dynamic range set, I could have all of this information in the single picture, rather than my having to slide up and down on the dynamic range scale of what I'm shooting. So high dynamic range has some value in pictures. Here's another example going back. That's the same picture. You can see the kind of dynamic range that's in the picture. And so I can pull all sorts of things out of a picture. The other thing that's important in having a larger bit depth is the kind of contouring that's happening in people's pictures. People say that 8 bits is enough. It's not. And the only way you're going to know it's not is to see a 10-bit picture or a 12-bit picture versus an 8-bit picture. Even if the bit depth isn't dynamic range, the bit depth can be seen in contouring in someone's face, where you see steps in someone's face instead of a smooth smooth gradation in someone's face. And this particular picture, which is an 8-bit picture, when I show it on my 8-bit display, you can see the contouring. When I show it on my 10-bit display, the contouring is almost gone. So there is absolutely a need for a better bit depth, even today, for every single thing that we're broadcasting. And so with that, I'm going to yield the floor.
Okay, I think a first applause there for Joe. That is indeed the fastest I've seen him go through that many slides. Mark Schubin, you're next up.
Thank you, Jeff. I have a 5-word takeaway for you. 4K should not be underpants. Now, what do I mean by that? Unless you're Superman, you put your underpants on first. Superman puts his underpants on after he puts on the other clothes. We're going to 4K, and by doing so, we may be precluding some of the things that Joe just spoke about. So could I have my slides up? Okay. This is something that appeared at the Society for Information Display Week 2014. It's a pentagon, and it talks about 5 different areas. Spatial resolution is 4K. Temporal resolution is frame rate. Contrast, we heard earlier about OLED. Color gamut, Joe just talked about. Quantization, Joe just talked about in the contouring. And it looks like all 5 are equally important, and it looks like the distance from the center to the outside is this regular step ratio. But let's look at 4K from 40,000 feet. Let's say I have a 4K set and it's pointing up, and I have an HD set and it's pointing up. Can you see the difference? I think even Tim will agree you cannot see the difference between the two at 40,000 feet. So what happens at closer viewing distances? Well, here are some viewing tests that were done. The first 2 are by the European Broadcasting Union. The third one is by the Swiss Federal Polytechnic Institute. The European Broadcasting Union has gotten very similar results, and I've normalized them all for the same vertical axis. So the vertical axis is how much bang the consumer gets for the buck. On the left, we see 4K. Absolutely, you can see it. Tim says you can see it, and he's absolutely right. Even on a 56-inch set, it's not that different from a 49-inch set. The red line is what you get at a normal viewing distance of about 9 feet. He was talking 10 feet, that's fine. The black line is what you get if you're really close to the set. In this case, it would be 1.5 times the height, or about 3.5 feet away. And there is an improvement. It's statistically significant. There's no question about it. But it's not a lot. It's half a grade, even if you're just 3.5 feet away from the set. Now, in the next set of results, that's what you get if you're increasing the frame rate. And you get a full grade of improvement for every doubling of the frame rate. And then the third one is showing what happens if you increase the contrast ratio. That's what Joe was talking about with the high dynamic range. And you see a tremendous increase as we increase the contrast ratio. Now, we talk about resolution as though it's something that we can just say, okay, 4K, 2K, whatever, but we watch motion pictures. We don't watch static pictures. So the 2 pictures I have down at the bottom have exactly the same spatial resolution. Call them both 4K, call them both HD. They happen to be HD in this case. Notice that the ties and the tracks are identically sharp, but the locomotive clearly is not as sharp. And so here's a homework assignment for you. Go on the web, search for an artist by the name of James Nares, N-A-R-E-S, and he has an artwork called Street, and you'll be able to see a 2-minute section of it on various videos that are available. It'll be shown to you in HD, and it'll be the sharpest pictures you've ever seen because they were shot at an extremely high frame rate. So frame rate should be the underpants, not 4K. Thank you.
Excellent. Mark, thank you. Pete, you're next.
Great info. Thanks very much. Put my slides up, please. I'll try to build on what we've just heard. I agree that the spatial resolution for 4K is nice to have, but it's not necessarily the ultimate solution. Slides, please. And I know that the industry has been looking at many aspects, there we go, including what we've heard about in terms of frame rate, high dynamic range. Let's see, here we go. We know that both NAB and CES being in Las Vegas tends to want to make people gamble on which of these terms is going to be most effective. But I think the key question is, will consumers really benefit from? Will they pay more, and will they enjoy more what these different image attributes do? And that brings us right down to this, which is the nature of the human vision system, which is far more complex than many people take up to mean. It operates very differently than a CMOS or CCD sensor. You can't simply look at the photoreceptor size and calculate what the visual acuity is. Your eye is seeing different frame rates at different colors, at different luminance levels, in a very complex fashion. As a matter of fact, the retina of your eye is actually considered by physiologists to be not part of your eye, but to be part of your brain. That gives you some idea about the complexities and how to put this together. So if we consider the benefits of 4K spatial resolution, first of all, it has to do with viewing conditions. Most appropriately, how far away you are. The Lechner distance of 9 feet kind of limits the visible size of the 4K display. But also the ambient light and other conditions. It also has to do with the artistic intent on things like the motion, scene contrast, and depth of field that goes into the image. And it has very much to do with system engineering, because a 4K camera going through compression, going to a display, could look very different depending on things like the lens selected, the type of compression, the type of interfaces, and the processing. All of those have to be pristine and carefully considered in order to preserve that degree of spatial resolution. As an example, we've talked about viewing distance, and to build on what Mark said, for a 60-inch set, the viewing distance, in theory, to be able to see it with normal 20/20 human vision is just over a meter. So that's far closer than anybody's going to sit, which is what leads many people to think you need larger sets. This is a nice chart that Carter Bale has on his website, and this shows the relative viewing distance versus necessary screen size for high definition, standard definition, and ultra high definition. And if we look at the far right there, you see that if you want to be looking at 9 feet away, consider the average distance in the US household, then you need a very large set, bigger than this one. It'd have to be 140 inches diagonal if you really, truly want to benefit from the full spatial resolution. So in summary, on spatial resolution, it's a good thing. It looks better on certain types of content if you're sitting very close, but real life conditions may be different. For example, if you want to use motion, especially at 24 frames, there is no 4K information in this shot. And it could be done with an 8K camera, it doesn't matter. There's simply no information in that image that has that degree of spatial resolution. Second example is artistic content, such as a depth of field, a commonly used cinematic technique to direct the viewer's attention to a specific item, but that means that the majority of the image has no high resolution information whatsoever. And here's yet another example that you may not be as familiar with. If you ever watch computer graphics for special effects in a movie, there is no 4K information. The rendering cost and the time involved in rendering 4K effects is cost prohibitive. And even in the most large budget motion pictures, the tentpole movies that you see in the cinema, even those that are released in 4K, like Spider-Man, all the special effects are in 2K. So that means that the content is going to be limited. So what else can we do with that? One idea is that a 4K panel, on the other hand, provides an opportunity for oversampling. So here's an example of a diagonal line reproduced in close-up on a high-definition display, and that same diagonal line with pixels half the size vertically and half the size horizontally. Ultra-high definition, I have 4 pixels in the physical space that I used to have 1 pixel in for high definition. definitely an improvement. And that's the reason that upconversion of high-def material in a 4K panel could be a very attractive solution and almost indistinguishable from, quote, native 4K transmitted through a typical food chain. So in conclusion, the things that you want to be looking at beyond just the spatial resolution have been talked about already: dynamic range, frame rate, color gamut. There's been a lot of news about high dynamic range, spectral highlights. In real life, when I'm looking at you at the audience, I'm probably looking at over 1,000,000:1 contrast ratio because I've got a really bright light up there and really dark shadows in the back. That's very unlike anything you can get on a display of 2,000 or 3,000:1 contrast ratio. We could do much better, and you would notice it much more. Secondly, frame rates. The human eye, at a minimum, needs to see 20, 25 frames per second in order to create continuous motion. But even over 60 frames per second, there's still a significant difference that the eye could see. Here's a slide that Mark used earlier, illustrating how motion blur is an important factor in considering image quality. And here's a chart also from the ITUR showing the observed difference. On the left, that bar is 60 frames per second, 120, and then 240 frames per second at the right. So you can see that there's a significant improvement in people's visual understanding of the image between 60 and even 120 and even 240. So, and this is at 720p. It's going to be, 1080p. It's going to be even more pronounced when you get up to 4K. There's a lot more we can do in terms of color gamut. I think this is an example showing the benefits of quantum dots, but you're going to see the same thing as you increase the gamut out to 2020. And I think Joe has some good points about the difficulty in narrow bandwidth colors when you get out to the edge of the locus. So we need to look at that much more carefully. And finally, we haven't talked so much about immersive sound, but that's something that we're finding makes a huge impact in cinematic releases. Right now, there's lots of work going on in the studios and content creators for object-based sound with things like the DTS multidimensional audio system and Dolby Atmos, but also ambiosonics and wavefield synthesis. These are all things that were impossible 10 years ago, practically speaking, because we didn't have the CPU processing power. Now we can do them, and they should be a part of our planning. So it's a very complex ecosystem that involves lots of things that I would encourage you to read up on these, both the ITUR BT 2020 specification and the SMPTE HD ecosystem are available online for free. Thanks very much.
Thank you, Pete. You may have noticed that there were a number of things from all three of these previous speakers that are not quite yet in the sets that were being discussed earlier today by the manufacturers. The things you can buy in the store, some of the things that these experts believe are on the horizon and will make a big impact on your future television viewing. One of the mechanisms that is out there that is important, and Pete just mentioned it, is the work of the various standards groups, putting together these various ideas, sorting them out, figuring out what it takes to implement, put all the parts together. And we're going to hear now an overview of what kind of coordination is going on from the perspective of the CEA, but also some of the other organizations that Brian works with.
Thank you. All right, here we go. So again, I'm Brian Markwalter with CEA, and I know Joe asked if people have been to Las Vegas. Well, if you haven't been to Vegas, then you probably shouldn't be in this room. I hope you've been hope you go every January. All right, so we've talked about trains. I want to talk a little bit about chicken and eggs. So there's a guy I used to work with, Phil Zimmerman, who's famous. He's a brilliant, irreverent guy, privacy expert. He's the one who thumbed his nose at the feds and released pretty good privacy and an early email privacy program. So I want to paraphrase Phil, because a lot of these panels, I think we're past this now. A lot of these panels got positioned as TV manufacturers are too far ahead. I think from everything we've heard today, that's no longer the case. It's really about which kind of aspects of a really great picture are we going to be able to deliver at what point in time. So I think really at this point, we're there with TVs and partner content providers, and so I'm hoping we're a little bit past this chicken and egg discussion and really on to what's going to arrive when and how much content we have available, which is a good thing because as it turns out, the chicken and egg problem apparently can't be resolved. I found two very reliable resources on the internet who have conflicting views. One from the Institute for Creation Research and the other from HowStuffWorks.com. So everybody's hit on these before. This is a similar version to what Mark showed that was taken from Display Week, the Sony presentation there. We're really working on kind of 5 areas of technology progress in these displays, and we're just able to achieve different ones at different points in time. So we've got to resolution. We're at 2160p. Frame rate, you'll see why I'm sort of indicating roughly here where we are at a certain point in time. But 60p is doable now with the release of HDMI 2.0. Dynamic range is a really complicated discussion. It involves the whole chain from camera to display. Bit depth, we're clearly able to do 8 now. There will be 10, and we'll keep moving up. And then colorimetry or color gamut, obviously we're built on 709. There's this projection of BT 2020. There's some other things. The movie industry has some other color gamut techniques that they use that may show up. I didn't show any kind of waypoints along the way here. But this is how I see the progress in what's happening with Ultra HD displays. So back in 2012, CEA released a definition for, or a characteristic, a list of attributes for ultra high definition displays. And the point of that was really to sort of get a handle around what we knew would be coming out at CES. So this was late in 2012. We knew at 2013 CES there'd be a lot of showing of ultra high def displays. We wanted a name that we could kind of rally around. We did some consumer research. And, but at the time, there weren't many standards really in place. We were at HDMI 1.4. There's no, I think even HEVC was not released at the time. So today we're announcing an upgrade or new release of this definition where we're able to capture some more of what's going on here. This will be available to everybody. I wanted to go ahead and put it all in print here so that slides and you'll be able to get our release later today. These attributes are not particularly new or astounding. The resolution really hasn't changed. Aspect ratio, clearly we're in a widescreen world. Up conversion, the reason this is in here, you've heard it talked about a great deal today, but this is critical because it guarantees that all the legacy content will be shown and shown well on Ultra HD displays. Now, as we move ahead, so in the digital input, we wanted to be clear. Our previous definition had additional input, but we couldn't point, and I wanted to highlight here the 60p. So now the technology and the standards are in place. Partway through last year, CEA released an update to a standard called CEA 861. That's the basis that HDMI is built on. So right after we released our standard, HDMI leveraged that to release 2.0. And now we're able to reflect that in our definition. Colorimetry, we point to 709 as a floor for the color space, but make it available that TV manufacturers can support other standards. And this is left to the marketplace, but as the whole food chain gets worked out, we'll be able to maybe point to a higher colorimetry. Bit depth, like I said, we know that we can do 8-bit. I think we'll see 10-bit TVs, and it'll increase from there. So one thing that's new, we have released a connected Ultra HD companion definition to our base definition. So first bullet basically says, do everything else that we just, all those previous bullet points that explain what ultra high definition display is. And add to that a codec, and as what is probably not surprising, relies on HEVC. And our definition includes a little bit of detail as a footnote about HEVC, since, as you know, the HEVC has a wide range of parameters. Audio, this audio definition simply says you got to do multi-channel. There's an expectation. As was talked about, Pete mentioned, there's a lot going on, some really interesting work on next generation or immersive audio that needs to settle out a little bit before we could provide any more detail in a definition. Then the last two bullets really say through IP connectivity, this is the essence of the connected definition, you need to be able to provide an app or service that delivers this Ultra HD content to the consumer. So this definition is really about setting kind of a floor of expectation and interoperability for the consumer that guarantees they'll get a good Ultra HD experience. And then I think I'd wrap up. We've done some consumer research that we've talked about in the past. I know there's some retailers going to be talking a little bit later today. They can probably give you the on the ground assessment of what's happening in stores. The research we've done, where we've actually intercepted and talked to consumers, it's clearly a seeing is believing story. We're going to, Sean mentioned this in the opening presentation, we're going to come out with a new forecast, and we can already tell, based on feedback we've gotten from manufacturers in our research, the number is going to go up quite significantly in our forecast for the remainder of this year. And I think that's it. So I'll hand it over.
Thank you. So I think from those four, very rapid fire, and thank you, gentlemen. We left some time for some Q&A here. Subject matter, I think, for a number of follow-on lectures, articles, blog posts, et cetera. Not the least of which in your last bit there, the parameters of the new declared. You'll notice that several of the things that I think the other gentleman mentioned that are not quite within the reach of the existing interface specs, for example. Unfortunately, in putting this program together by scheduling availability, we weren't able to get anybody from either HD-Base-T or Steve Venuti from HDMI or the DisplayPort folks. All of them are working in the area that Joe pointed out. In order to get all these extra features, certainly to get all of them, but even maybe a significant advancement in some of these new features, the pipe that connects the content into the TV set is not a trivial exercise, and it requires a lot of effort to figure out how to make it work and move it forward. And I think I'm getting head nods from everybody on this. I think you've also gotten a hint here of some of the things that are more interesting than just the number of dots on the screen. We may argue about whether the dots help the picture. They certainly are bringing people into the stores. They're bringing the new kind of way of looking at television into the living room. It's now going to be up to a lot of people to work together to figure out how best to commercialize what we do next. But we'll talk in the next panel some things that I think you'll see that already there is a value proposition being delivered and groundwork being laid. I will point you to the website as well, and we're going to encourage each of these gentlemen to speak with Scott on camera and elaborate some of the points they didn't cover here. I also will tell you that on the website we had a good interview with Chris Cookson, who is our virtual keynote for this address, not for the on-site here, but rather on the web-based. And Chris, of course, brings a background from being in production and making 4K content workflows and the like, and also having worked in manufacturers where 4K was introduced. I encourage you to come to the website. I had a good conversation with Chris in a venue that we'll talk about in the next panel, so you'll see a lot of the real stuff in the background as Chris talks about where the near-term future is going. At this point, questions from the audience. Rick.
Thank you. Great presentation showing all of the things that can be done with UHD. The slides earlier that showed improving color gamut as part of the new CEA specification, higher frame rate. There are no women on the panel. Women would appreciate, or our surveys, cover rendition ahead of perhaps frame rate and such. So do you see this as something that's going to be defined by the industry as to what it will like, and the industry is largely male, and yet the film viewing audience is largely female? And they tend to appreciate a larger color gamut than most males are born to appreciate. So how do you see these things balancing out between what the industry would like to have there, approximating the theatrical experience, sort of what's deliverable to the consumer audience, which is increasingly female, with the color and attention, so above frame rate and HDR perhaps.
Do you want to speak for
Go ahead.
the SMPTE side?
Well, SMPTE is certainly looking at that as part of the ecosystem, but no conclusions. I think that even more interesting is that the content creation community in Hollywood, especially the American Society of Cinematographers, has been looking seriously at this and doing test footage even to understand how one would use that from a creative intent standpoint. I mean, the truth is that you don't want to exaggerate the colors, as is often done now with consumer sets, where a red is moved way out to a position where it never was intended to be. However, the creative community is now very seriously looking at how to take advantage of this, and that will help inform future color standards, I'm sure. I think many people are looking at what Joe said, which is BT 2020 may not be the answer for a variety of reasons.
Yeah, I think, too, I would like to point out the comment on the female. While it's not represented in the panel, the SMPTE organization that just got referenced looking at this is president's a female, as is the executive director. So there are women in very significant positions in the industry that are a part of this process. And I think
I don't know if others wanted to comment. So I agree this is a complex area. I think the displays are able to do better now. I mean, we can clearly reach wider color gamut. So from, I think, the manufacturing, the display end, we want to get it right. So you can clearly get some things wrong if the TV is processing, if you don't have the right standards in place, and the TV does the wrong kind of mapping in color space. So that's where I think we want to be most careful and making sure that from capture and production all the way through to display that the standards connect together properly.
So, all of this improved color space and everything can either be solved, I guess, by having, it's going to take more data that needs to be transferred from the source of the video through to the display, right? So that can be solved either through a bigger pipe or through compression. Now, I noticed in your standards, Brian, you were talking about having compression to H.265 on the display to decode data that's coming through the internet or through Wi-Fi. But why not also through HDMI? Because it seems like HDMI is going to become the bottleneck for being able to get a lot of this stuff through. And unless they start allowing compressed data through there, we're going to have more and more unwieldy HDMI cables that are going to have to be thicker and thicker and shorter, or else do crazy stuff like DSC that's being discussed by MESA, like compressing, decoding a compressed signal, then recompressing it again just to pass it down the HDMI cable.
Sure. So even though I referenced HDMI by name, the definition does not. So we talk about having digital inputs. Today, those are uncompressed inputs. We're agnostic about the technology. It happens that HDMI 2.0 raised the bar up where we could do certain things. My slide about the lanes of progress, though, what's built into that, whether it's the pipe to the home or the sort of the local pipe from your video sources to your display, those are always some form of bandwidth limited, and we have, frame rate, we have spatial resolution, we have color, we have more bits, and those are all competing, for the display. And what we'll get to will be able to, based on content, hopefully, you can adjust those. So maybe sports content spends more bits on temporal resolution than, say, movie content.
If I may, that's what I'm getting at when I say that 4K should not be the underpants. If you want to go from 8 bits to 12 bits, that's a 50% increase in data rate. If you want to go from 60 frames per second to 120 frames per second, that's a 100% increase in data rate. If you want to go from either 720p or 1080i to 4K, that's an 800% increase in data rate. So we're creating the bottleneck immediately that's going to prevent those later improvements. A 50% increase in data rate, no problem. A 100% increase in data rate, no problem. But if we're starting with an 800% increase in data rate, big problem to add anything else.
Couldn't we be wearing our
Exactly. Right, but we can't make 4K the driving force because it's what's precluding everything else.
I just wanted to follow up a little bit on Joe Kane's recommendation on DCI color space. It makes a lot of sense. It's easier to do. We go to the movies, we see DCI already. That's the colors that we see that we know already. DCI is, a lot of the panels are almost ready to do DCI. We have content. There's no reason to create new content for a color space that's slightly bigger. DCI is what we're familiar with. DCI is obtainable, and we have a ton of content in Hollywood right now, ready to go.
It's the best answer I have for that is at the moment, I don't see 2020 being practical, so I believe that we are going to settle in on something less. I actually believe that we have to decide on a specific set of options in color. We can't make it anything from 709 out to some limit. I actually do want to see enough options in the system so that it will make it easier for the program producer in metadata to say, I want this displayed in a 709, or I want this displayed in P3, which is the DCI. I want this extended dynamic range. I'd actually like to see enough options in the UHD system so that the producer of the program is going to decide what they want out of the display, and they're going to send data to the display and say, for my program, do this.
And it should be noted that the DCI community is currently looking at how to expand the color gamut beyond the current P3 on account of the advent of laser projectors that could have a much wider gamut.
Just a very quick question. Is there any place talking about advanced sports and frame rate? Is there any place to see a truly amazing viewing of the soccer game today?
Yeah, where can we see 4K soccer?
Marty, and you plan everything else for CE Week. Where's the best spot to see high frame rate soccer games today? Yeah, they don't know.
Good question.
Actually, I believe, I can't remember who's doing it, but most of these big sporting events for the past year and in the near future are being shot in 4K. So
BBC's out there with 4K. We can't see it.
I remember 2 years ago here upstairs playing soccer, and the 3D, and the ball seemed like it was going to hit you in the face. I'm surprised no one has mentioned the Intel technology, seeing how they're a big sponsor of this conference. They're not here today. Their wireless technology. And has anyone seen the HP Dreamcolor monitors? These are the monitors that the producers of the movies use. And they're just out of this world. It's cost prohibitive to put it on 52 inches, but it's just perfect color.
It's only perfect color if every person watching the content that's created on those monitors has the same monitor. Otherwise, it's useless.
For the content created.
Yes.
So that's
yes.
eventually.
Content is created to a specific color space. And the only way you're going to see what is intended by the content is if you can replicate that color space. So someone's idea of color, the name you mentioned, someone's idea of color and producing, it doesn't matter how wonderful it is. If everybody doesn't have it, it's useless.
We're out of time.
5, 4. Folks, thank you very much. Thank this panelist, and do encourage you to get on with us on the website for the follow-up.